because it gave us increasing, decreasing intervals and the possibility of max min. And then the second derivative, it gave us the shape of the graph, not holding water, and where it changes concavity. Okay, very good. Other questions for me? Anything else? Is there anything else? We have not looked at word problems yet. I want to move on to section 3.3. And this is all about graphing, to finish the graphing, and then we look at word problems. So in 3.3, we're going to continue the same thing, but for rational functions, which are more sophisticated than polynomial functions. And I'm just going to start with an example. Now let's open on page 305. They're slightly more time-consuming in a way. Okay, I'm just opening the book. I'm not sure why it's so slow. Page 305. Okay. I wanted to say something before it finally opens. Rational functions are functions that may have asymptotes. This function can never have asymptotes. It's polynomial. It will exist everywhere. For any x value, I can find a y value. Well, what does these asymptotes, what do they mean? Okay, so here's a function with a vertical asymptote. A function with a vertical asymptote cannot cross the asymptote. So it may look like this. In other words, as we know, rational functions are not defined when the denominator is 0. So for example, if this is x equals 3, the function may be 1 over x minus 3. As you see, x minus 3 cannot equal 0, so x cannot equal 3. And this is a vertical asymptote, VA, vertical asymptote. And the function cannot cross it because it's undefined here. And as you see, what does the function do? As x gets closer and closer to 3, the function value gets closer and closer, closer and closer to infinity. On the other side, if x gets closer and closer to 3 from the right, the function values get closer and closer, closer and closer to negative infinity. So this is a typical rational function that is undefined at 3. It exists everywhere else, but not at 3. Also, notice something else. This function can, in the way I graphed it, also has a horizontal asymptote. Y equals 0. How come? Yes, as x approaches infinity, the function values get closer and closer, closer and closer to 0. Y equals 0 is the horizontal asymptote. As x gets closer and closer to negative infinity, the function values get closer and closer, closer and closer to 0. And that is the horizontal asymptote. This is HA, horizontal asymptote. There are other functions, which I am going to show an example if you want to, but I'm not going to test you on, who do not have horizontal asymptotes, but may have something called slant asymptote. So how something like this will look like? Okay, I put in a slant and a vertical. So the function may look like this, getting closer and closer to the asymptotes, always. I think that this is more than what we need in this class. So I can show examples like that. If you want, I will not test you on this. I will not put a problem like this on a test or final exam. So this is different than what we studied so far. The asymptotes. Everything else is the same. We are going to use the same table. Everything the same. Okay, so is the book finally open? Wonderful. 305. Good. I like to choose a rational function. Simple one, like 35. Very simple. Everything we studied so far is valid. In addition, we have asymptotes. That's all. So f of x equals -2 over x minus 5. And this is on page 305. We're asked to do the same thing. What? Everything. Good. Can anyone give us the domain of this function so you can see what is different? Can anyone give us a domain of this function, please? Please.
Well, there's all real numbers except for 5.
Excellent. Here's how we write that. And you don't have to write it again. Look here, please. Any number of lines that you want, it doesn't matter. This really means that the domain is everything but 5. Which means, in this case, x equals 5 will be a VA. There is a catch. There is a catch, and I'm going to write it in parentheses. Except if I have a situation like this, x minus 5 times x over x minus 5 times x plus 1. I don't care what I have in the numerator. I don't. I'm saying x cannot be 5 and x cannot be -1. Now I look and see what I have. I have to state the domain on the raw equation. But now, as you notice, something very interesting happens. This factor disappears. This one stays. This is a vertical asymptote. Because the factor of x minus 5 disappeared, this is not a vertical asymptote, but a hole. A hole in the graph, like this. Because the factor disappeared. Here, I drew the conclusion immediately. There is no factor that will simplify with x minus 5. Because of that, this is for sure the vertical asymptote. But if the factor disappears, so except in this situation, if the factor can be simplified, that is a hole in the graph. The factor that stays is still there at the end of the day. That is a vertical asymptote. It cannot be simplified with anything. There is no factor of x plus 1 at the top I can simplify it with. So for a rational function, which is a ratio of two polynomials, if the denominator is 0 at a point, like x equals 5 in this case, and this factor cannot be simplified, this is guaranteed to be a VA. If it can be simplified, it's a hole in the graph. But that's not the case here. Now, I have to plug in 0. When I plug in 0, I get 2 over 5. I have to find these limits. See, you thought that we got rid of limits for good. No, they're coming back. Remember what we said, the limit of -2 over x minus 5 when x approaches infinity or when x approaches negative infinity. Anyone remembers what we did with this?
Doesn't it get closer and closer to 0?
Absolutely. Thank you very much. Because the numerator is a tiny little thing and the denominator goes to infinity. So small over huge will always approach 0. Thank you. So 0, 0. What does that mean? Y equals 0 is a horizontal asymptote. How come? As x goes to infinity, the function values get closer and closer, closer and closer to 0. So this must be a horizontal asymptote. The same thing on the other side. Finally, I have to plug in the function, like we did for the limits, of course, 4.9 to the left of 5 and 5.1. I know the answer. I know the answer, but I don't know the sign of the answer. It's -2 over infinity, negative over 0, so it's infinity, but I don't know the sign. So just plug in 4.9 here. No calculations are required. Just give me the sign. Plug in 5.1 here. No calculations are required. Just give me the sign. As you see, I didn't even put them in the table. I'm not going to use them. I'm only using them for the sign. Can anyone plug in 4.9 and just give us the final sign of the answer?
Wouldn't it be positive?
Yes, because 4.9 minus 5, this is negative with negative at the top. Thank you very much. It's positive. Can anyone plug in 5.1 now? They may be the same sign, so don't assume. Calculate. I mean, just look.
That one's negative.
Yes, because the denominator is positive and the numerator is negative, so it's negative. Done. I have finished with this row. There are no x-intercepts. When x is 0, this is y-intercept. There are no x-intercepts because if you remember, a fraction is 0 only if the numerator is 0, but that's not possible. Good. Now, of course, I'm going to make my life as easy as possible and change it like this so I can differentiate quickly. If I don't, then I may mess it up because I have to use the quotient rule, la 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 la. So -2 x minus 5 to -1, please. Let's find the first derivative. So can anyone give us the first derivative of this? Anyone, please?
is it 2 times x to the fifth to the negative second?
Yes.
2.
Times the inner function prime, which is 1. Excellent. Let's also find the second derivative since we have it here. Negative 4 times x minus 5 to
-3.
yes, times the inner function prime, which is 1. Perfect. Now here, remember this is 2 over x minus 5, everything squared. But this cannot be 0. And it's undefined at 5, but so is the function. So there are no critical numbers. It's never 0. A fraction is 0 when the top is 0, but the top cannot be 0. So the function cannot have max-min because it doesn't have critical numbers. Can anyone give us the sign of this expression for ever and ever? It's never 0, so yes, sorry.
Wouldn't it always be positive?
Absolutely. Absolutely. Everything is positive because it's squared and the numerator is positive. Absolutely. Excellent. Now I'll stop and say, wait a minute, wait a minute, wait a minute. Don't go anywhere. You have to check that these two rows go well together. If they don't, I'll say, oops, I made an error. Because the first derivative is always positive, the function must increase forever. If the function does not increase forever, then I made a boo-boo. I made a big mistake somewhere. If the first derivative is always positive, the function has to increase forever. Now I'm checking to see if my numbers are working well accordingly. So from 0 to 0.4, yes, that's correct. It increases. From 0.4 to infinity, yes, it increases. From negative to 0, yes, it increases. Now I will study the second derivative. So here's the second derivative. The second derivative is a different story. How come? Because it's negative 4 over x minus 5 to the third. This can never be negative, but x minus 5 to the third can be positive and also be negative. So I have to be careful now. So let's study the sign, because I need the sign here. I need the sign for the second derivative. It's never 0, of course, the same thing. There are no inflection points because it's never 0. It's undefined when x is 5, but so is the function, so no discussion there. So we know that the sign depends on x minus 5. Let's put a number to the left of 5 in here and find the sign. Let's put a number to the right of 5 in here and find the sign. You have the option, or either put this in the graphing calculator and plug in 0 in it, but it's too easy. And the other option is plug in 10 and find the sign. Let's do this together. Let's plug in 10 first on the right-hand side of 5. This is positive. 10 minus 5 is positive. Cubed is positive. The numerator is positive, but there is a minus in front. So what will be the sign to the right of 5? We plugged in 10. This is positive. This is positive. This is negative. What sign do I have here? It's okay if you're wrong. What do you think?
Negative.
Yes, thank you very much. Which means the function has to open downward. Now let's plug in 0. 0 minus 5 is negative 5. But negative 5 to the third is negative 125. The numerator is negative, the denominator is negative. What is the sign to the left of 5? I plugged in 0, negative, negative. I need the sign. When I plugged in 10, positive, negative.
Positive.
Perfect. Which means the function opens up. See, I was not able to verify anything here like I was a few minutes ago because there is no max min. So here it makes sense. It has to look like this. Yes, it does. Here it makes sense. It has a local minimum. It has to look like this. Yes, it does. But here I was not able to verify because there are no critical numbers. There's no max min. So I had to calculate. That's all I need. The problem is done. Nothing else matters. Don't look anywhere. That's all we need. This is it.
I have a question.
Please, please, please.
So does that apply for all rationals that they'll never have a max or a min?